Good day everyone. Today, I'll be presenting my datasets entitled Default of Credit Card Clients. In this video presentation, I'll cover the dataset's purpose and significance, the preprocessing steps applied, and the data mining techniques used, such as clustering, association, and classification. I'll also share key interpretations and results, followed by a summary and recommendation for the datasets owner. Let's get started. What exactly are these datasets about? This dataset is about customers' default payment in Taiwan and compares different methods for predicting the likelihood of default. It contains 30,000 instances with 23 features, making it a rich dataset for analysis. Why these datasets? Basically, I choose these datasets because it emphasizes its real-world relevance, comprehensive features, large sample size, and its classification task. Word relevance reflects real financial scenarios. It deals with credit card default predictions, a genuine issue faced by banks and financial institutions in managing loans and credit risk. It also improves decision making by analyzing customer behavior. It helps create data-driven insight for better loan approval and risk assessment policies. It also applies to daily life. Understanding default payments relates to real-life financial management, both for individuals, example, credit card responsibility, and organizations. And lastly, it encourages problem solving. As a student, working with these datasets sharpens skills in solving meaningful, real-world challenges using data mining techniques. Comprehensive features. Diverse data points with 23 features, the datasets capture various aspects of customer behavior, such as payment history, credit limit, and bill statement, offering a complete picture. Then, it improves model accuracy. Having multiple features allows for better predictive models, as they can analyze relationship between different variables and outcomes more effectively. It also captures complex patterns. The variety of features help identify patterns and trends in customer defaults that might not be obvious with fewer data. This dataset is considered as large sample size. It improves model reliability. A large number of data points reduces the risk of overfitting and ensures that the model generalizes well to the new data. It represents real-world scenarios. With 30,000 instances, the dataset captures a wide range of customer behavior, making the analysis more applicable to real-life financial situations. Then, it increases statistical power. A large sample size leads to more accurate and confident statistical conclusions, as there's enough data to identify meaningful patterns and trends. And lastly, this dataset is considered as classification task. Binary classification problem. The dataset involves predicting one of two outcomes, default or no default, which is common and practical type of classification problem. It also considered as real-world application. This task closely aligns with real-world financial decision-making, such as determining the creditworthiness or managing loan approvals. And then it supports risk management by classifying customers as default or non-default. Financial institutions can proactively manage risk and minimize potential losses. What is the importance of these datasets? First, it is considered as financial risk assessment. It provides insights into predicting credit cards default, which is critical aspect of risk management in financial sector. Second, real-world problem solving. The datasets helps bridge the gap between theoretical learning and real-world application by focusing on a genuine issue faced by banks and financial institutions. Then, it is considered as model building and evaluations. It's an excellent resource for practicing various machine learning techniques such as classification, regression, and probability estimations, and understanding customer behavior. By analyzing the data, we can gain insights into factors influencing customers' defaults, which can be applied in financial data mining. And lastly, skill development. Working with these datasets improve skills in data pre-processing, feature selections, model building, and evaluations, which are essential for a career in data science or analytic data processing. What pre-process did you make? In this dataset, I used data cleaning, where in this process it involves removing or correcting irrelevant, incomplete, or inaccurate data. Then I use handling missing data, wherein this technique is an essential in data processing to ensure accurate analysis. Makikita sa interface na mayroong zero missing data na nagpapakita lamang na ang datasets na ito ay accurate at walang nawawalang data. In the selected attributes that represents the ID of each client, there are zero missing data, 3001 distinct nominal type of attributes used, and 100% uniqueness of the data. Why data cleaning, handling missing data is important? Napakahalaga ng data cleaning at handling missing data para sa accurate at reliable na analysis. Ang incomplete o inaccurate na data ay maaaring magdulot ng bias na resulta at hindi epektibong models. Sa pag-aayos ng missing values, nagiging mas consistent ang dataset at nagkakaroon ng mas maayos na basehan para sa decision making. In the next presentation, I will focus on the evaluations of the clustering and classification result. I'll analyze how well each technique performed in terms of accuracy, interpretability, and real-world applicability. The clustering results will be assessed based on the coherence of the form groups and their relevance to the problem at hand, while the classification outcomes will be evaluated using metrics such as accuracy, precision, and recall. This will provide a comprehensive understanding of how these data mining methods contributes to the overall analysis and decision-making process. First, gumamit ako ng classification task, wherein classification is a supervised machine learning technique used in Weka to predict the class label of an instance based on its attributes. Weka provides various classification algorithms like decision trees, naive Bayes, support vector machine, and etc. Makikita sa screen na gumamit ako ng J48 algorithm as an implementation of the C4.5 decision tree has been selected for classification with specific parameters, wherein confidence factor for pruning is 0.25 and minimum number of instances per leaf is 2. Then, meron din sa screen na 10-fold cross-validation is chosen to evaluate the model, meaning the data is split into 10 subsets, and the model is tested on each fold while training on the remaining. Dumako naman tayo sa confusion matrix, wherein this is a confusion matrix that evaluates a classification model performance. Rows represent the actual class labels, columns represents the predicted class labels, and each entry, ij, indicates how many instances of class I were predicted as j. From the confusion matrix, class B or 2 has 14,030 correctly classified samples, and class C1 has 10,585 correctly classified samples. And lastly, class D3 has 4,917 correctly classified samples, and so on. However, no instances of A education, F4, G6, or H0 were classified correctly. It appears that classifier may be heavily biased towards certain classes, B, C, D, leaving some others AH either underrepresented or misclassified entity. Overall, the result shows that the correctly classified instances is 46.77%, wherein it is equivalent on 14,030 out of 30,001, and the incorrectly classified instances is 53.23%, equivalent for 15,971 instances. Then, sa datasets na ito, gumamit rin ako ng clustering, wherein the photo shows the use of Weka expectation maximization or EM clustering algorithm. It evaluates class to cluster mapping for a dataset containing 30,001 instances and 25 attributes. The setup indicates clustering on the training data with class attributes X3 ignored for unsupervised cluster analysis. Shows a scatter plot visualization from the Weka Explorer, likely representing the result of clustering or classification for a datasets involving default of credit card clients. The axes X and Y represent nominal variables, while the different colored cluster represent groups or classes based on the variable education. In this scatter plot visualization from Weka, the cluster represent group of data points categorized by education attributes, displayed as different colors. Each cluster corresponds to a unique value of education variable, with the data being distributed along axes X14 and X13. And the types of the attributes is nominal attributes. Here's an explanation of the clusters. Yung color red cluster represent as education level 2. Likely represents clients with a specific education level such as college graduates. It is positioned lower on the y-axis, indicating consistent characteristics based on the feature represented on that axis. Then yung color green naman na green cluster ay nag-represent ang education level 1. It represents another group with a different education level, potentially higher than level 2, placed slightly above the red cluster on the graph, which could indicate a difference in the distributions of certain financial or demographic variables. Then yung cyan cluster ay nag-represent ng education level 3, a distinct group of client with another education level, distributed in the middle of the graph, showing overlapping but distinguishable patterns compared to levels 1 and 2. Then yung pink cluster naman ay nag-represent bilang education level 5. This cluster is sparser and positioned higher, which may signify clients with a higher or more diverse education level. And lastly, yung color yellow cluster ay nag-represent siya bilang education level 4. This group is even higher on the graph, reflecting unique characteristic, possibly advanced education or other outlying factors. After analyzing these datasets, dumako naman tayo sa summary, wherein the application of data mining techniques, specifically clustering and classifications, provided significant insights into the datasets. Clustering effectively identified natural groupings within the data, highlighting patterns that can guide targeted strategies. Classification proved to be a reliable tool for predictive analysis, accurately categorizing data and offering actionable insights. The result reveals trends and relationships that were previously undetected, showcasing the value of data mining and understanding and leveraging the datasets. After I end this video presentation, I would like to recommend 3 recommendations for the datasets owner. The comprehensive analysis of the datasets has revealed its potential to drive meaningful insights and strategic decisions. To maximize its value and ensure long-term usability, the following recommendations are proposed. Number 1. Ensure data quality and integrity. Regularly validate, clean, and update the datasets to maintain its accuracy, consistency, and completeness. Address any missing, duplicate, or inconsistent data to improve overall reliability. Number 2. Adopt advanced analytical tools. Invest in tools and technologies that can handle diverse data types, perform robust analysis, and generate actionable insights beyond clustering and classification, such as regression, analysis, or time series forecasting. And lastly, Implement data security and governance. Establish strong data security measures to protect sensitive information and implement governance policies to ensure compliance with regulations and ethical standards.